You can go.
Okay. I'd like to welcome everyone to our presentation. We're the ADA team. ADA standing for the Ancient Inscription Database and Analytics. And it's a web page and database used to study, research, and analyze ancient inscriptions, currently including the languages of Linear A, Korean, and Festus Disc. And the goal of the page is to help researchers try and crack the code behind these languages. Our sponsor is Dr. Peter Revesz. He's a professor and researcher at UNL and owner of the original ADA system, which he handed to us to make improvements on as well as add new features. On our team, we have Braden Klein, a senior software engineering major, who's our development manager. Shane Clegg, our senior computer science major, who's a squad lead and product manager. Joining me today, Isaac Askey, a senior computer engineer. Suab Sheikh, a senior computer science, and myself, Troy Ogden, a junior software engineering major, as well as we have our project manager, Melanie Kugler-Wright, and our tribe lead, Shruti Bowman. So I'll hand it off to Suab to talk about the problem and solution.
Yeah, so the problem that we were presented with this project was really just the usability of searching inscriptions. It used to be tedious and not user-friendly. So in a few slides, we'll show you some screenshots, but essentially what was happening is users were, the way that the inscriptions work is that there are symbols that are representative like words in the language, and researchers have a large database where they have a bunch of inscriptions that they are trying to decipher or have deciphered. And to access this database, you would have to search in a bunch of symbols and you would get a table returned back to you of what those symbols were and what those descriptions and meanings were. And before, what would happen is each symbol has an ID associated with it, a 3-digit code, and you would have to look up the symbol and then find the 3-digit code and then type in the 3-digit code followed by hyphens and search a large string of those texts. And that was how you would search in the previous iteration of the website. And the previous iteration also didn't have Unicode support for it, meaning that when you got a return table back, you'd have to take the 3-digit codes and find their corresponding symbols again to decode it. And so the solution we had for this was to build a virtual keyboard for each language rather than using a 3-digit sequence. So now users can find the symbol, click a button, and then hit submit, and they get returned a table with that sequence in the proper Unicode format. So this is a screenshot of what the previous iteration of the website used to look like. As you can see, you have the search by Cretan, Linear A, and English, and at the bottom you have a table which the boxes would be what symbol it is, and then the 3-digit ID associated with it is underneath it. And so you would take those 3 digits and then put them in the search bar, followed by a hyphen if you wanted to add more, and then you would hit submit. And when you hit submit, this is what would show up. And so you get a linear A sequence, and you take these 3-digit values, find the symbol that they were associated with again, and then that's how researchers were decoding and translating these back then. So the solution we built now is a front-end React paired with our database, which is MariaDB, and this is to allow users to search for the inscriptions and transliterations. So if you can see in the screenshot, we have little buttons at the top to search by each language. And whenever you click a button, it populates with a virtual keyboard at the bottom with the corresponding symbols for that language. So if you were to click any of those buttons, a 3-digit value would be associated with them that we handle in the back end. But you click those buttons and then press submit, and then you would be presented with another table in the next slide. So yeah, this is the table that you would be shown with. So this is a little more nicely formatted. It gives you the total number of results and has a little pagination at the bottom. So if you have a lot of results, then you can click to the next page of the table. And it gives you the meaning, the linear A sequences, the cognates, syllabic values. And as you can see, all of those, like in the linear A and syllabic values, the proper symbols are put into those fields. And so it's easier for researchers to start using them and decoding them and furthering the symbols and the meanings of them.
Solution built continued. So Researchers also are in need of quantitative data regarding like relationships between symbols. And so a lot of times you'll want data like corresponding to if a symbol, appears before another symbol right before it, like what are the occurrences of that? And so the solution we had was a syllabary pair matrix. And so basically we have an entire matrix, and then in each cell is the number of occurrences for each pair. So the left side of the matrix is the symbol that comes before, and then the top the columns would be the symbol that comes right after that preceding symbol. And then it should be noted that we have three different types of matrices. So this is just one. The other two have a different semantic relationship between the symbols. But basically, these matrices just give researchers insight into how there are different relationships between sequence or symbol pairs, and sometimes semantic relationships can be derived from that. And so it's just a very good thing to have as far as research wise goes. And then teachers wanted to add another ancient inscription into this system, it would be relatively easy with how we implemented the keyboard, and reusability is very high with that. So it'd be relatively straightforward for like another team or whatever to add another keyboard. Yeah. And then value and highlights continued. So for us, this was a great introduction to React JS and front-end web development in general. And it is in a sense a full stack web application. It's database backed, and so we have a middle layer as well. We utilized Express.js to bridge the gap between the front end and the back end. And so having all of that exposure and being able to learn how the information flow works was very nice, and we learned a lot from that. And then we also learned a lot about Unicode and how some languages are not supported by Unicode. As developers, we often take for granted um, the the vast nature of Unicode and how it supports virtually anything you can think of. Whereas with these ancient scripts, it wasn't until recently that they were supported. And so luckily we were able to look into that and find font families that were able to support it. It's kind of a unique issue, and we learned a lot from that. And then we also kind of learned about how our system would benefit researchers. And so we kind of got like a researcher perspective with developing the matrices and how the quantitative data can really help establish more, critical thinking regarding how these ancient scripts work and semantic meaning behind different components and the building blocks behind them. And then, we also learned about a lot about just interacting with sponsors and stakeholders in terms of communicating and the whole development process. Having our sponsor meetings every week, and then our release meetings too, and doing demos and having presentations. We learned a lot about the flow of how processes work with development in general. All right, that concludes our presentation. Thank you for attending. Are there any questions?
Hey, you guys, I hope, this is Marie, and I came late, and I'm super interested in this project. So if after everybody is done with their questions, could you start back over again? I just want to know what this project was about. Thanks.
Of course.
Sure.
I believe another team's taking the room after us, but we have a table. You can come visit if you'd like.
Oh, okay. Yep. That's what I'll do is I'll go to your table.
Would
Yeah,
you like
that
the
works.
link for that, or do you know where to find it?
I do know where to find it. Thanks. That's a good
Awesome.
question.
Thank you.
Thank you.
Are there
Okay.
any other questions?
Yes, sure. I have a question. It's now time to demo the system a little bit with a few examples. You have time for that?
I believe we have a couple minutes to show it off a little bit. So this is the application we showed you in the screenshots. As you can see, we're on our home page, which defaults to the linear A keyboard. So if we wanted to, let's say, search for this first character here in the top left, we simply type it in. We click submit. After a little bit of a load time, we get it searches by subscript. So any script, any string that it actually shows up on will display, as well as any transliteration and in any of the sequences. And this is just useful for researchers looking for these actual scripts themselves, as well as
Just enjoy looking at it, everyone. This sequence is just so remarkable. Normally, not a single sign is understandable. Everything is so strange. So this is what we face. Very difficult to write in this script, type in this script, and store the data, retrieve data. That's very nice. Go on.
okay, then I'll head back to the home page, and as well as we can also search by cretin and Fastos disk. So like if I go in here and I click the first symbol again, click submit. Obviously, Fastos disk doesn't have as many sequences, but we still do get results. And then if we head back to home, we actually have our statistics page. So we can go to our syllabary matrix, and within here, it's split between 3 quadrants. And yeah, I'll load the 4 quadrants. I'll load the first quadrant. And as we said before, like the before and after of the sequences, depending on if you search in the syllabary, the beginning of block or end of block. But I believe, yeah. Is there anything else you guys would like to see?
Again, you are a little too fast, but this matrix is very important. A lot of cryptography techniques are dependent on good statistics. And the syllabic statistics here is that which pairs occur with what frequency. So the left in the rows is the beginning, and in the column, the next one immediately following pair, and how frequently these pairs occur in all the inscriptions. Absolutely necessary, and it's very good that you as computer scientists did this, because it was never available for scholars who have studied linear A. They never had a database system, which of course can do it, and you have done it very nicely. But
Guys, sorry
they
to
just
interrupt.
looked up paper,
Dr. Revesz,
published books.
I'm sorry to interrupt you guys. The next team's about to arrive, but this is a super interesting application, and I think a lot of people want to hear what you have to say, Dr. Revesz. If we could just take you guys over to the virtual table, I think everybody could enjoy continuing this conversation over there and seeing more extensive demo.
Yeah.
Thank you very much, guys, and great job.
Awesome.
Thank
Thank you. We'll see
Thank
everyone at
you.
our table.
Thank you.
Thank you.
Thank you very much.
All right, thanks for joining us for this presentation. In a couple of minutes at 4:15, the Nebraska Family Dentistry team is going to present. As a reminder, a full schedule of the presentations can be seen on the UNL Senior Design website.
Should I just go ahead and share my screen right now?
Yep, go ahead.
Everybody can see it?
Yep.
Okay. And we're recording?
Nope, in just a
Oh, yeah,
minute.
okay.
All right, just about to press record. So whenever I do, you'll be good to start.